Welcome everyone into the third day of this edition of EVConIndia. I, on behalf of Blue Circle, would like to take a few moments to thank all our partners for putting their shoulders to the event. A special thanks to our main sponsors, Log9 Materials and Hero Electric, knowledge partner Alvarez and Marcel for creating the white paper, investment partner Indian Angel Network for co-authoring the Startup Ref program, accelerator partner Huddle, and real estate partner JLL. It's been an absolute pleasure working with their teams and getting their valuable support. Also, a big shout out to all my team members for working all the hours to pull this off. Thank you also to our distinguished audience for joining us, most of whom were CEOs, CXOs, and senior leaders. Many among them are our members and are repeat visitors to our webinars. This is very encouraging and motivates us to provide even higher levels of dialogue. For those of you who are new with us today, India-based startup Blue Circle is the world's first sector-specific opportunity and knowledge exchange networking app for business leaders. It is somewhat like a sector-specific LinkedIn for senior leaders, a space to have meaningful conversations, connect with over 15,000 plus rapidly growing community of like-minded leaders from India and across the globe, exchange high-quality curated content, and access business opportunities across 20 sectors, such as e-mobility, energy, real estate, and many more. Coming to today's discussion, it is a privilege and a pleasure to welcome Robin George, Vice President, Log9 Materials, our distinguished keynote speaker, who was handpicked because of the think input and the rich experience he brings in. Robin has 6+ years of expertise as an energy storage researcher, nanotechnologist, and techno manager across various reputed academic and industrial institutions. Passionate about innovative product launches by adopting cutting-edge technology. Robin has successfully filed multiple patents and research publications in concurrent fields by implementing various products via stages of prototypes. Exposure to a multicultural workforce and inspiring them with novel ideas with the eminent touch of creativity is his strength. Bridging the research and development by solving complex imagination through the right aspiration for a better universe is his vision. And now coming back to the discussion will revolve around the topic roadmap towards making India self-reliant in electric battery technology. Now I request Robin to please begin the session. Thank you.
Thank you, Gautam, for the kind introduction. And it's my pleasure to associate with Blue Circle and share the knowledge about how to make India self-reliant in this ecosystem specifically. So I would take a couple of seconds to share my screen. Hopefully the screen is visible for everybody.
Yeah.
So my topic for today is the roadmap towards making India self-reliant in electric battery technology. So without much introduction, I would like to start the presentation by saying, if you can look into the slide, the India map at this point of time, what we can see is like we have a different set of challenges than the world today is facing in the EV technology. The first one is the high temperature, because we know the temperature at Delhi and at Chennai is extremely different from what is it in Jammu and Kashmir. And the driving patterns and the infrastructure is extremely different from the European and US context. And the vehicles that we use, the premium way, the early stage vehicles that Europe use will be the luxury vehicles for India for at least for 2 to 3 years. So why all this scenario happens is because we fall in a geographical belt called tropicalized region, where rain is so often, so that challenge from the water floods, and the temperature can rise up at any time because it can go up to 45 degrees towards 49 degrees. And sometimes it can go even 10 degrees, even to 5 degrees at a certain extent. So are we able to tackle all these problems with a universal solution? No, because that's why a lot of OEMs and people are getting challenged, because they are thinking that batteries and EV technology, which are made for Europe and US, which is baked and cooked for a particular climate conditions, will not be succeed in India. So what what should be our approach, how to make a reliable battery and EV technology. So today I wanted to touch three major points. When we talk about any sort of batteries, being a battery scientist, there are three major commercial sectors people wanted to adopt. One is like NMC, two is LFP, and third is LTO. Each of these sectors have their own pros and cons. So when we wanted to make a reliable technology, it's so important that we have to understand the chemistry is stable, then the design of that particular battery technology is stable, and the third thing, that process is sustainable. If we can achieve all these three dimensions of any battery technology, then it is a right technology to adopt, and it will give significant impact in the society in terms of environmental challenges, or in terms of reliability, or in terms of sustainability. The first point I want to advise or suggest for this reputed audience is, what is the right source of chemistry? So I wanted to quickly gain your attention to understand this, what is happening in NMC and LFP. You saw this one in NMC. What happened is, like, while charging, or the ambient temperature, when it gets increased, it quickly goes suddenly, and it tends to blast, and that's what we are seeing. And in LFP, what happens is, like, at 150 degrees Celsius, it actually triggers a smoke, but it will not essentially blast. So why does it happen? Simply because if you can understand the anode of the battery, there is something called SCI layer, where the SCI layer is act as a protective layer for any sort of blasting. But what happens in NMC, when the temperature it try to gain, the oxygen, the free oxygen tend to react with SCI layer, and it tends to blast quickly. So why it is not happening in LFP? Because that the SCA layer tends to, that breaks. LFP doesn't allow too much oxygen to go free in the system, since it is comparably safer. So then why Europe and US is going to NMC? The simple answer to that question is, they are always curious about long range. Should we need that much range in India? That's the choice. So and the second problem is, every new technology that is going to face is the supply chain issue. And we know that NMC contains crucial elements like cobalt, lithium, nickel, and India really doesn't have all this metal. But in terms of LFP, the only thing which lacks in India in terms of supply chain is the lithium. But we have a good promoter for iron and phosphorus, including aluminum. And I'm also pleased to introduce LTO, that chemistry, even that India got huge resources of titanium, aluminum, and manganese. So it's when we are adopting a new technology, it's always important to understand that we have to adopt a technology which got solid supply chain, and so that we doesn't fail to understand the challenges later. So that's why Lognan introduced a concept called TIB, this tropicalized ion battery, which essentially trying to solve the challenge rather than adopting a technology which is meant for some other geography. Understanding the temperature issue, the parity, the cost parity, and everything, we have to develop our own chemistry. And why it is important, you can understand that if you can understand a little bit of chemistry, it's quite sure that we can't always mix up high voltage cathode and high voltage anode. It should be either opposite. It should be either high voltage cathode versus low voltage anode, or it should be low voltage cathode versus high voltage anode. So I would really suggest and recommend the people who are listening to me at this point of time to not just adopt a certain technology because it is working for China or other Asian countries or Europe or US for that matter. Let's have a clear understanding about what technology and what chemistry is sustainable in the Indian conditions. And what we are trying to do is, like, there is two major challenges of LTO. One is the cost, And the second is the energy density. So what Log9 is trying to do is to modify the chemistry according to the Indian context so that we can reduce the cost as well as to increase the energy density of the LTO so that we can always avail the good part of the LTO, which is the cycle life, where LFP and NMCs are offering me around 2,500 to 3,000. LTO can easily go up to 15,000 cycles, considering with the high temperature performance. So what we are also not dropping the LFP for that matter. What we are essentially doing is to create LFP and tune LFP in such a way that we can increase the energy density at the same time to increase the high temperature performance. So the chemistry is sorted. Once the chemistry is sorted, the second important parameter to address and make energy independent or self-reliant India is to understand which form factor I should adopt. There are three major form factors. As we all know, it goes like cylindrical, pouch, and prismatic. Each of these form factor have their own pros and cons. But which one to select? For example, cylindrical, there is a limitation to go for bigger form factor of the cell. This pouch cell is really might good for the mobile phones and for the smaller application. Is it really a safer option for bigger systems like two-wheeler, three-wheeler, and e-bus for that matter? No, because the pouch cell, the casing is pretty thin and it can really cause the safety issues and it can really raise the flag for safety. And we don't want to, and we don't have any luxury to do that. So even though the energy density of the pouch cell is high, still we have to consider people's safety first. So there is no room for pouch cell for EV technology at this point of time. So, and the last technology that majority of the people are doing in the conventional system is the prismatic cell. But let me take you in a different aspect. Yes, prismatic is good, but understanding the conventional design, we always vouch for cylindrical cell, because right from the pressure cooker in the kitchen, the tanker which carry the flammable liquids like petrol and diesel, the oxygen cylinders, the hydrogen cylinders, everything comes in a cylinder. And that simply means that cylindrical shape can hold more pressure. And why we would consider that is that in India, considering the fast charging and multiple charging sockets, we have to be cautious, and it's always good to have a preventive measure in the case of design. And that's why I really wanted to suggest to go for cylindrical cells. But how? Because in cylindrical cell, I can easily go for 18650 cells, 2170 cells. Can I go beyond that? Yes. That's why, what are the advantages of cylindrical cost? That we can always go for lower cost cylindrical cost, because the throughput of cylindrical cells are much higher than any other cells. So it's easy to put a cylindrical cell process manufacturing line than the prismatic line, considering the lesser waste management, because it's also important to understand, to have a better production capability, we should always focus on the efficiency. Not today, but at least for the coming years, it's very crucial, and it's going to crucial to have lesser wastage, because it will help to reduce the cost of the system. So what we are trying to adopt is like, how we can go for a cylindrical form factor is to adopt a technology called tabless technology, which we were using for supercapacitor and ultra capacitor, and it's very much relevant for to adopt that technology for EV batteries, because we can significantly reduce the internal resistance of the cell. And that's why, and the idea is to increase the size of the cell, and by adopting this tabless technology, we can actually shoot up the energy by 20 times and the power by 24 times. So the 2 points we got covered is like the chemistry, we have to be careful, the form factor and the shape, we have to be careful, and the last part of my presentation is the process. Can we adopt some good processing techniques in such a way that it can impact the EV system. For example, can we adopt aqueous binder technology instead of organic binder technology? Why that is important? Because any technology that we are making is not, obviously it should be safe, it should be good in performance, but it's also important to understand the ecological impact of that project. So we are also adopting a technology which is safer to the environment, and it is helping us to reduce the cost by eliminating some of the crucial cost, by eliminating a couple of dry rooms for the coating and the downstream process, and reducing the capital investment for the dry rooms, because those who are working in the cell manufacturing industry know the pain of the cost of the capex at least. So by adopting aqueous process, we can actually enable all these parameters. And the second, the important key that the industry is facing is the time of proper formation and aging. Because even though, since in India, a lot of manufacturers are importing the cell, they are not understanding the key concept of formation and aging. But it's a time to understand the key concept and aging, because if your cell is not properly sorted and properly conditioned by the different formation cycles and aging, it can easily, obviously, it can bring down some cost, but it can cause your safety. Because if one of the cell is not properly undergone these condition and thorough testing, it can actually take up a life. So it's also important to do a proper formation and aging with a proper sorting technology. And since it consumes 25% of your floor space and cost, we are also innovating that process in such a way that we develop a new formation and aging protocol which required 40% of less time, 35% of less equipment, and it essentially reduced the cost of the cell manufacturing process. But we are again ensuring that formation and aging process are properly done, so that we make sure that we have a thorough QA/QC before the cell goes into a pack. And that's all for my keynote for today. I like to re-summarize these points in such a way that we have to be cautious about chemistry, we have to be cautious about the design and the form factor, and we have to be cautious about the process. And if we can do all these three and do some innovation on each and every aspect of the cell manufacturing setup, I do believe that India can be self-reliant in the battery technology in the coming years, and that's our motto and mission. And thank you, Blue Circle, and for providing this valuable opportunity to speak out about the current challenges. And it was a wonderful opportunity. Hope you enjoy. Thank you.
Thanks, Robin. What I'll do is quickly get into the Q&A session. We have 3 questions which I'd like to ask. One is by a person called Rahul. He's saying, is LFP, I know you touched upon this, but he's saying, is LFP a solution towards making India self-reliant? And the second part is, where does India stand in alternatives to lithium and cobalt, like sodium, aluminum, and sulfur to produce batteries?
So Rahul, I just wanted to thank you for the question. So yes, I do. I'm not saying that LFP is the only solution, but LFP can be a good solution in comparison with NMC, because NMC, we have 2 issues. NMC, the first issue is temperature issue, which is very crucial for India. And the second thing is that most of the exotic materials goes into NMC is not going to LFP. But LFP, as it is a solution, yes, it can be a solution for some time, but it's also important to modify the LFP, and like we can do a coating on the LFP, and you can tune the electrolyte so that it can work at higher temperature without blasting off. Yes, in comparatively, an LFP is far, far better and suitable for India. That's what I believe.
Thank you. Thank you. Move on to the next question by Rajan. He's saying, which is better for India, aluminum ion or aluminum air batteries?
I do believe that aluminum air and aluminum ion batteries are used for different contexts. If you are looking for a long interstate travels, always the aluminum air batteries are better because it got highest energy density in the entire battery industry. And aluminum ion is an upcoming technology. We have to wait and see whether it is a cost feasible option. If it is not cost feasible option, even though we got aluminum as a raw material in India, we have to yet work on to make that aluminum as a battery grade material. So aluminum ion might take up some sort of market in the small hole technology, but for long haul, aluminum air is always better.
Thank you. I'll move on to the next one by Anushri. She's asking, why is ethanol seen better in Brazil compared to electric? Could it be an option for India's decarbonization?
See, we got a lot of, we have to understand this net zero concept is not just because the way we drive the vehicle. It also starts from the manufacturing, from the mining, or from the cell manufacturing process. So overall, if you understand, yes, some sense ethanol would make, but once it converted into a scale, once it converted into a scale of 10 gigawatt hour to 30 gigawatt hour, which is the prediction for India in 2030, obviously the technology is in scale will overtake the conventional technology and the upcoming technology. So I do believe that even though it is good for Brazil, in India, this once we achieve 30 gigawatt hour, which is a prediction for 2030, will definitely overtake that portion and will make it more greener. And we have to adopt it on a mass scale to make it more sensible.
Thank you. Thank you for the thorough answer. I'll move on to the last one. And if there are more questions, please do share it in the Q&A section. It's from Pidambra. He's saying, which is easy and cost saving for recycling?
I'm not getting which is easy and cost saving. Are you asking about the chemistry? Are you asking about the form factor?
Maybe I think he's talking about LFP, LTO, and the first slide which you had spoken about. Or Pitambara, if you could just be a little more precise.
But I try to answer is the chemistry basis. So people now are coming with an argument like NMC will be cost saving in terms of recycling because you get more exotic material out of that. But my question is like, why you wanted to pay just because you have an recycle option over there? It's better to go for a sustainable technology on the first stand because it's always prevention is better than cure. So I would still bet on LFP for that matter.
Okay, done. So I think we'll just wait for another minute or two if we have any other questions. Otherwise, so I guess, okay, if we do get any other question, Robin, I'll surely mail it to you and await your response for the same. But thank you very much for an insightful and engaging session. I mean, I'm sure we've all taken home several technical, valuable nuggets from this conversation. And thank you also to our leaders in the audience for joining us and for staying till the end and for always sharing excellent questions.
Thank you, Gautam. And I think it's high time to ask this type of questions so that the other technology in the world should not simply bluff us. So it's always always good to have this type of technical understanding on the fundamental basis so that we can be cautious when we are acquiring new technology.
Thank you so much.